bearing a roll number 24951A66G5 of branch CSE AML section C, course differential equation and calculus, topic transformation of coordinate axis. Introduction to coordinate systems. Coordinate systems provide a framework for representing points in space. They can be Cartesian, polar, cylindrical, or spherical, among others. Understanding transformation is essential for various applications in mathematics and engineering. Types of coordinate systems. The Cartesian system uses perpendicular axis for representation. Polar coordinate system. Polar coordinate system expresses points in terms of angles and distances from a reference point. Spherical coordinates extend this concept to 3 dimensions using angles and radii. What is transformation? Transformation refers to the process of changing the position or orientation of points in space. It can involve translation, rotation, scaling, or sharing. Transformation are fundamental in computer graphics, physics, and robotics. They are very common among all those. Translation is different from transformation. Translation moves every point of shape by the same distance in a specified direction. It is defined by a vector that indicates the shift in each coordinate. In a Cartesian system, the transformation can be expressed as x comma y in terms of x plus a comma y plus b with open and closed parentheses. They cannot be expressed by using flower brackets. Rotation of axis turns a shape around a fixed point, usually the origin of the coordinate system. The angle of rotation determines the new position of the points. In 2D, the transformation can be expressed using trigonometric functions. Open and closed parenthesis x comma y gives rise to x cos theta minus y sin theta comma x sin theta plus y cos theta. In mathematics, rotation of axis in 2 dimensions is a mapping from xy Cartesian coordinate systems to an x dash y dash Cartesian coordinate obtained by rotating the x and y axis counterclockwise through an angle theta. A point P has a coordinate x comma y with respect to the original system and coordinates with respect to the new system. In the new coordinate system, the point P will appear to have been rotated in the opposite direction, that is clockwise through the angle theta. A rotation of axis is more than 2 dimensions is defined similarly. Coordinate systems are essential for the studying the equations of curves using the methods of analytic geometry. To use the methods of coordinate geometry, the axes are placed at a convenient position with respect to the curve under consideration. For example, the study of the equations of ellipse and parabolas. The foci are usually located on one of the axes and are situated symmetrically to respect the origin. If the curve and hyperbola, parabola, ellipse, etc. is not situated conveniently with respect to the axis, the coordinate system should be changed to place the curve at the convenient and familiar location and orientation. The process of making this change is called transformation of coordinates. The solutions to many problems can be simplified by rotating the coordinate axis to obtain new axis. Scaling changes the size of an object while keeping its shape intact. It can be uniform, same forms in factor in all directions, or non-uniform, different factors. The transformation can be represented as x comma y. Open and closed parenthesis gives rise to open and closed kx comma ky, where k is the scaling factor. Shearing distorts the shape of an object by slanting its sides. It can occur in one or more directions, altering the angles different axes. The transformation can be expressed as x comma y in open closed parenthesis. Homogeneous coordinates. Homogeneous coordinates are an extension of Cartesian coordinates, allowing for easier transformations. They introduce an extra dimensions, enabling representation of translation using matrix multiplication. A point x comma y becomes x comma y comma 1 in homogeneous coordinates. The equations defining the transformation in 2 dimensions, which rotates the xy axis counterclockwise through an angle theta into x dash y dash axis, are derived as follows. In xy system, let the point P have polar coordinates r comma alpha. In the x dash y dash systems, P will have polar coordinates r comma alpha minus theta, x equal to r cos alpha, y equal to r sin alpha. X dash can be written as r cos alpha minus theta equal to r cos alpha cos theta plus r sin alpha sin theta. X dash and y dash. On further solving, we get xy cos theta minus sin theta cos theta, which is written in matrix. Matrix representation of transformation. Transformations can be represented by using matrices for efficient computation. Each type of transformation corresponds to specific transformation matrix. Matrix multiplication allows for concentration of a multiple transformation into a single operation. Through a change of coordinates, a rotation of axis and a translation of axis, equation can be put into a standard form, which is usually easier to work with. It's always possible to rotate the coordinates at specific angle. Composition involves combining multiple transformations into one. The order of transformation matters and can lead to different final results. Rotating before translating yields a different outcome from a translating before rotation. Inverse transformation undo the effect of the original transformation. Each transformation has a corresponding inverse, such as rotating back or translating in opposite direction. Finding an inverse is crucial for applications like computer graphics, re-rendering. Computer graphics applications, transformations are fundamental in re-rendering scenes and animations. They enable the manipulation of objects and camera perspectives in a virtual environment. Efficient use of transformation enhances performance and realism in the graphical theory. Next slide says about the transformation in robotics. Robots are transformation to navigate and manipulate objects in their environment. They rely on coordinate transformation to understand their position orientation. Coordination transformation, which is used, limitation and challenges. Certain transformation may lead to loss of information, especially in dimension reduction. Numerical errors can occur during competition, affecting accuracy. Understanding the limitations of transformation is essential for effective applications. Some future developments in technology will enhance transformation techniques in various fields. Research into more efficient algorithms and methods continue to evolve. Future applications may include more complex real-time transformative in augmented reality. Summary of key concepts. Transformations play a vital role in numerous scientific and engineering disciplines. Understanding various types of transformation is essential for practical applications. Mastery of transformation techniques leads to better problem-solving capabilities. Conclusions. Transformation in coordinate system are fundamental across many fields. Continued study and application of these concepts will yield innovative solutions. Please feel very easy to ask these questions. Thank you.